Talk go on with WebRTC. This is Mauro Pompilio, and he will speak about VMUX. Mauro is a full-stack developer. He likes Ruby, he likes Node, he lives at London, and let's upload him for his talk.
Hello, everyone. This talk is very related to the previous one, actually. It's a WebRTC project I've been working on lately, but it's in a much smaller scale. It's just me working on this. As he said, my name is Mauro. You can find me on Twitter there. And VMUX is a project I started like a few months ago to basically reproduce the functionality you have now in Skype, but using WebRTC technology. So you can have like chat and video Skype, video call in the browser, but without using any plugins or Flash or the need to install anything else. And it's also being built on top of WebRTC. Is peer-to-peer and is encrypted and secure. So I'm going to go about WebRTC a little and explain how it works. So I've seen that there's a lot of people that is aware of WebRTC, right? Can you raise your hands? So, okay, I'm going to give a brief introduction about how it works and then explain a bit how VMUX handles all the WebRTC stuff. So WebRTC is like a really exciting project that's been going on for like a year, maybe a bit more than a year. And it's basically it's a set of JavaScript APIs. I'm going to go back. It's a set of JavaScript APIs that enable you to access input/output on your laptop or on your system without needing to install anything else. If you think about products that already exist, like Skype or Google Hangouts or like any other proprietary system, usually it's really hard to integrate with other stuff. Sometimes you have to install, like in the case of Skype, you have to install applications. You need plugins for Google Hangouts, etc. And the advantage of deploying something that runs on WebRTC is that it's almost everywhere. You don't need to be aware of like building your application for multiple systems because it basically runs on the browser and the browser takes care of it. Basically, it's like very big abstraction layer on top of that. And it's been advancing really fast in the last few months. So now you have WebRTC that ships on Chrome, on Firefox, on Chrome for Android, on Firefox for Android, Opera, and then you have also like bindings, native bindings. If you want to do something like it's a WebRTC client that runs on your like Android app. So it's like almost everywhere. It's quite ubiquitous. And then this is what it does basically. It's a set of JavaScript APIs that give you access to input devices in your system. So let's say the laptop, the camera, and the microphone. Then there's another set of APIs that allow you to communicate with a remote peer directly from your browser. And you can send arbitrary data with using a different one. This is abstracted in these three APIs basically. The media stream, which is for audio and video, the RTC connection, and the data channel. The media stream is just this called, you see here, it's called actually get user media. And what it gives you is a synchronized audio and video output. And you can, when you instantiate this, when you call the navigator get user media, what you get back is a media stream of your camera and your microphone synchronized. You can also pass constraints, like you can pass the resolution you want, if you want multiple resolutions, if you're on like well, this is abstract actually. If you're in a mobile phone, you can choose what camera you want to use, etc. The RTC peer connection is kind of like the main component on WebRTC, and it abstracts you from a lot of other stuff. So it does all the signal processing for you, does all the encoding for video and audio. The codecs that you use are royalty-free and open source. Like Google bought the company that used to do VPA, and then they released it openly. And handles security. So with the communication between each peer is encrypted. They exchange fingerprints when you do the signaling, and I'm going to talk about that in a minute. And bandwidth management. This is basically how it looks like. It's like very, very simple. When you have basically callbacks where you can say when you get a remote stream that is a video or audio, and then you can do something with it, like attach it to like a video element on your page, or the same thing with your local stream, and then you can create offers to offer just like the local descriptions you have to someone else. And then you have RTC data channel that once you have established this connection between the two browsers or the two peers, you can create this data channel that is to send just arbitrary data. And it's kind of, the interface is the same as the WebSocket interface, so you can just send messages, anything you want. It's encrypted with DTLS. And you can choose if it's reliable or unreliable. That means it's kind of like TCP or UDP. You choose if you want like every message, or you can like just deal with discarding a few of them. So the signaling, the way to establish the communication between the two peers, you need a way for them to discover each other. That is called signaling in the WebRTC world. And basically, the two browsers will talk to some like central server that will help them discover each other. And I didn't say that actually the signaling is completely abstract in the way you can exchange them. So you can use any method you want. This cloud here basically represents your signaling system. It can be, in the case of VMUX, I use WebSockets, and then both partners connect to the same server to exchange the signaling. But you can use, I think the GT guys use XMPP, and then you can just like allow for any transport really. They will exchange the session descriptions, basically through the signaling server, and then they will establish the peer-to-peer connection between them. The thing is that you already have a way to discover the two peers, but you probably need to go through NAT, or probably behind NAT, because you'll be like in a private network or something. So there's ICE, which is a component also of a part of WebRTC, and basically the two servers discover each other using the STUN protocol, which helps them. They basically, in the session description, there's information about the STUN address, about how they can traverse the NAT from one side to the other. And if that fails, then you can have an optional relay server that has to be public, so both partners have to be able to reach it, and then they can like basically share, relay all the packages between them using the relay server. So what it looks, this is like a traditional, this is how it will work if the NAT traverser works. They basically do the signaling, and then they just connect through the NAT each other. And if you can't connect through the NAT, then what they will do is send all the packages through the return server. As I said, like by default, WebRTC, everything you send through this like peer-to-peer channel is encrypted. It uses SRTP for the video and audio, and then DTLS for the data. And you also you have to make sure the signaling is being done through a secure channel as well, and that way you're almost covered. So I'm going to show you quickly how VMUX works. This is VMUX deployed. So you can log in with your Twitter account or as a guest. Basically, it's just you don't need an account, you just put a name. I'm connected, so I'm logging in with an account. And I will try to call Barish with his up there and show if, well, I can call him. Are you there? Oh, wait. Call Barish. So there he is. That's Barish, him on the back. So you have this has a present system that works through the WebRTC, so through the WebSocket server. This is server side, and then once they establish the connection, they chat and the video stream are actually peer-to-peer from browser to browser. They don't go through the server. And then you can also do like join rooms, and this is kind of like the conferencing system Jitsi showed, but in a much simpler way. Nice. So basically, here everyone is connected to each other. Nice. So each of the participants is connected to each other. There's no central server that is actually relaying everything. The problem with this is that if many people join this, it will probably crash. There's actually no limitation right now, but you can probably handle like 8 participants, no more than that. I'm gonna leave the room. So you can find it. This is the URL, so you can go and try it like now. The code is also, there's a link at the bottom of the page with the GitHub URL if you want to check it out. And this is a stack that VMUX is built on top. It's a socket stream, which is a node framework that allows you to publish, subscribe, message passing, etc. And the front end, the back end is like really, really small, because the only thing it does is just message passing between the WebSocket clients. Everything else is built on the client side, and is built on top of Backbone. It's written on CoffeeScript. The authentication, I chose Twitter because I use it all the time, but actually it uses every auth, which is a node project that is like pluggable authentication, so you can use anything you want really. And if you want to start with WebRTC or try it and start building stuff, there's like really interesting projects. There's a main reference app from Google, which is AppRTC. And they have this really useful adapter.js, which is just it's a polyfill for like, because some of the APIs are actually namespaced with the like Mozilla, Moz, RTC, etc., or WebKit. And with adapter.js, you have like a concise way to use it. And Google also has like a stand server that you can use. You don't have to deploy like your own. You can use basically a public stand server they have available. They don't have any relay server, but it's good. If you want to do some debugging, in Chrome comes with WebRTC internals, which is built into the browser, and it will help you debug everything related with WebRTC. Very detailed information about like the connection, etc. And then there are some really cool libraries. You will probably know a few of them. Simple WebRTC is from the guy from Talkie.io, and it's like really, really nice library if you want to start building something on top of WebRTC that's like video based. There's a few links. ShareFest is basically to share files, because you can just establish the data channel without the video and audio stream, so you can use it to share files peer-to-peer in the browser. So you can just like drag and drop a file into your browser, and it will be sent to the remote peer. And obviously there are a few resources. I will publish the links to the slides afterwards. And that's it. Questions?
So we have time for some questions. I see a question at the front.
So what you did is, does it work out of the box if I download the code?
Yeah, you can try it.
What do you throw?
Yeah, exactly. You can clone it from GitHub and then just npm start and it will run. Oh, he was asking if what I showed, it runs locally. Yeah, you go to GitHub, you clone it, and then the only thing you need is a working node stack, having node in your laptop, and then you just install the dependencies when npm install and npm start, and you have like the same thing running locally. It's super easy to deploy as well. The only dependency you have is Redis, which is the key value store. It's available like everywhere, so that's the only dependency really.
We have another question at the rear.
Thank you. How do you manage the overheating when you have more than 2 or 3 peers? Because it seems to be the general problems when you encode and decode video between peers, and everybody has to make this CPU intensive operation.
Yeah. I'm not handling that at all in the application. Basically, what you saw on the video on the like conference system is not handling that at all. It's just basically connecting each peer with each other, and it's not limited. So if you have a fairly powerful laptop, it will work fine. If you are like on an old laptop, you'll probably have some problems.
I do have a crappy laptop, and I couldn't go further than 4 people. Otherwise, I was burned everywhere.
Yeah. You will have to use something like the Jitsi, probably, where you're just connecting with just one partner that is actually broadcasting to everyone else. There are like also commercial solutions, but the Jitsi one looks awesome. So.
We have a question.
Hi. What about SET RTP, the new standard?
Sorry,
do
what?
you support SET RTP? Not S, but SET.
That's
SET.
part of the WebRTC standard. Right now, the configuration is not specifying anything, so it's in the default one. But probably will be just like a matter
Because
of changing that
with
when you.
SRTP, you have to interchange the keys, the public
Yeah.
key. And with SET, they are auto-generated each session, so it is more secure.
Right. I didn't check it, but I will take a look and probably like just
It's
use that.
the Zimmerman, the creator of PGP. It's the one that did this.
Right.
new-
Is that available also on Chrome one?
Sorry.
It's available already on Chrome on Firefox. So.
I don't know if it's included in WebRTC. So,
Right. Okay. We'll
so the
take a look.
question was.
No, I don't know. I don't know really.
Okay. Okay. Thanks.
Thank you for your talk.